In this video, we will continue with base multiplications as they are used in Vedic math, and this is video number 4, part 2 of 3. I have split the base multiplications video in 3 parts. This is second part. In this video, we will discuss proportional base numbers, square of numbers ending in 5, and its variations. Okay, let's go next section now. Next section is we will use a proportionality. A random base number here just to satisfy your curiosity. Okay. Question: can I use a base other than natural base number? Sure, you can do it. It's Vedic math. It's very flexible. Okay. In fact, you can use any number for base number, and we would use a random number. But in Vedic math, the mantra is short and sweet, one line mental solution when possible. Okay, let's go continue. In that spirit, our first preference is natural base numbers, and the second preference is proportional base numbers. Okay, let's continue here. To satisfy your curiosity, we will consider an example of 97 times 98, and first thing we do is select a base number, and we would use a base number 95, which is close to these two numbers, but it's not a natural base number. So let's continue. So we have 97, 98, we know base number is 95. Now we go to compute my deviations now. Okay, 97 minus 95 is plus 2. 98 minus 95 is plus 3. So we got two deviations. Now we go to determine left, which is a crosswise. Apply crosswise. What we are going to apply? The plus. Operands are 97 and 3, and we are doing 97 plus 3, which is equal to 100. Okay, on the right we would multiply vertically 2 times plus 2 times plus 3, which is 6. Okay, 2 times 3 is 6. Okay, now compute the answer. Okay, it's not natural base number, and we don't know how many digits we need here because it's not. Okay, we would have to use the formula, which is base times left plus the right. Okay, answer is 95, which is a base times left plus 6 is 9506. Okay, you have it now. We use a base 95, which is a random base number, which has nothing to do with the natural base number or a proportional base number. And we were still able to compute 97 times 98 equals 9506 using a base number of 95. Okay, let's continue. So it's a we continue and consider a proportional base number. Let's see what that is. A proportional base number, these numbers are proportional to the natural base numbers. Thus we can obtain 30 from 3 times 10, 250 from 1000 divided by 4, this is a sub-proportional, and 60 from 10 times 6, and so on. So we can, proportional base numbers are proportional to the natural base number, and we'll use the sutra proportionality here. Okay, let's continue. Let's consider example 36 times 33. Here let's see what base number we use. So with 36, 33, now we're going to choose a base. The base number we choose is 30 equal 3 times 10. We obtain 30 from 3 times 10. 10 has a 1 0 on the right, so we would be allowed to keep one digit on the right. Okay, let's do the base number now. Now we're going to compute deviations. Deviation 1 is 36 minus 30 equals 6, and deviation 2 is 3. 33 minus 30 is 3. So these are my deviations 6 and 3. On left, we got to apply crosswise. What we're going to apply? The operator plus between 33 and 6. 33 plus 6 is 39, and so is 36 plus 3 is 39. So on left is 33 plus 6, 39, right is plus 6 times plus 3 is 18. So we have 39, 18. Now 18 has 2 digits on the right, and we only can have a 1 digit on right. Okay, continue. So 1 is a carry. Carry gets carried to the left. So answer on the left is 3 times 39. So we have to resolve proportionality first. 3 times 39 is 117. Okay, then we would carry this, use the carry here. So we need to resolve proportionality first before you resolve carry. So 117 on left plus 1 more, 118, and then 8 on the right. 1188. Okay, let's continue here. Another example, 36 times 33 again. Okay, and my base number is 40. This time we'll use a base number of 40, which I get from 4 times 10. Tirthaji called this a working base. So its working base is 40, which is 4 times 10. Okay. Now we go to compute deviations. Deviation 1, 36 minus 40 is minus 4. Deviation 2, 33 minus 40 is minus 7. Okay. On left, apply crosswise. 33, what are we going to apply? Minus. On the operands, 33 and 4. So it's 33 minus the operand here, minus 4. 33 minus 4 is 29. On the right, multiply vertically. Minus 4 times minus 7, which is 28. Okay, and we only need one digit on the right. Okay, so answer is, this time we'll say 20. We would use the formula here. What we say, left times the base plus 28. 29 times 40, which is base, plus 28 is 1160, plus 28 is 1188, is same number we got before. And if you want to do the other way, say 29 times 4 is 116, and 2 get carried from the right. So 116 plus 2 from right, 118. It's examples now. First example, 203 times 187. We got to choose a base first. Base is 200, is 2 times 100, which is a working base is 200, which I got from 2 times 100. We don't have to do the lines all the time. We should be able to do the multiplication. We know the steps. Okay, next, deviation 1, 203 minus 200, which is plus 3. Okay, 203 minus 200 is plus 3. Division 2, 187 minus 200 is minus 13. Okay, we're going to cross apply. We're going to cross apply first deviation with a first number with the second deviation. Okay, and the operation is negative. 203 minus 13, which is 190. Okay, right is 3 times minus 13 is minus 39. Okay, answer is base times left plus right. Okay, base times 190 times 200 minus 39. It is 38000 minus 39. It is equal to 37961. Okay. Also, on the right, we have 100 minus 39, which is add 100, subtract 100. 100 minus 39 is 61, and minus 100. So this is minus 100 here plus 61. Okay. Let's do the. We have to resolve the proportionality also on left. Okay. Left is 2 times 190. Proportionality is 2 right here. Number was 190 on left. 2 times 190, 380. Okay. Now this one negative gets carried to the left. Answer is 380 minus 1 from the carry and 61 on the right. Okay. And that which is equal to 37961. Same number we had before. Okay. Let's continue. Another example here. Example this time we'll take 3123 times 2998. Choose a base. Base is 3000, which is 3 times 1000. So working base in this case is 3000, which I got from 3 times 1000. Now the deviations. Okay. Deviation 1, 3121 minus 3000 is plus 123. Okay. Deviation 2, 2998 minus 3000, which is minus 002. I'm trying to keep it 3 digits on the right. Okay. So instead of saying minus 2, I say minus 002. That's a reminder that I need a 3 digits on the right. Okay. Left is cross apply. So we did a 3123, which is a first number here, and second deviation. what we do, apply negative, minus 3123 minus 002. I read this number like this: 3123 minus 002, which is 3121. On the right, resolve proportionality first. Okay, left is 3 times 1000. 3 times 3123 is 9363. Okay, and on right, it's a 123 plus minus 002, which is minus 246, and which is, after resolving the negatives, adding 1000 and subtracting 1000, I get negative 1754. Okay, answer is 936. One negative get carried to left, become 9362, and 754 from right. Answer is 9362754. So 3123 times 2998 is 9362754. Only multiplication we did was this multiplication. Okay, on the right, 123 times minus 002, which is easy. To 123 times 2 is 246, and sign negative sign here. And on the left, we did this subtraction here: 3123 minus 002. So we were able to compute this. Do some examples, more examples here. Example is 251 times 252. Okay, so the base is 250. How we get a base from? Dividing 1000 by 4. So working base is 250, which I got from dividing 1000 by 4. Okay, let's continue. Deviation 1 is plus 1. 251 minus 250 is plus 1. Deviation 2 is plus 2. 252 minus 250 is plus 2. Okay. Now the left part. Left is crosswise: 251 first operand and second deviation, and the sign is plus. 251 plus 2 is 253. Right is vertically multiply: plus 1 times 2 is equal to 2. So that's the only multiply we did. 1 times 2 equal 2 on the right. Okay, now we go to resolve. We do a base times left plus right. Okay, base is 1000 divided by 4, which is 1000 divided by 4 times 253 plus 2. 253 was left. This is the base here. So which is 253,000 divided by 4 plus 2. Okay, which is 63250 plus 2 equals 63252. Okay? So we were able to compute 251 times 252. Only multiplication we did was this one, or maybe if you want to call this a multiplication, adding 3 zeros to 253, that was, and then we divided 4. Okay, all right, so that's what we did. Okay, now let's another example here. 57 times 56. We take base of 50, and we're going to get the base from 100 divided by 2. I could have gotten the base from 10 times 5 also, but I chose this base to get from 100 divided by 2. So my working base is 50, which I get by dividing 100 by 2. Okay, let's continue. Deviation 1. 57 minus 50 is plus 7. Deviation 2. 56 minus 50 is plus 6. Now on left, apply crosswise. So what do you do? 57 first operand and second deviation. Operation is plus. 57 plus 6 is 63. Okay, on the right, we multiply vertically. Plus 7 times plus 6 is plus 42. Okay. Now answer is base time left plus right. Okay. So on the left is 63. 63 times 100 divided by 2 plus 42. Okay, that's 6300 divided by 2 plus 42, which is 3150 plus 42. Okay, which is 3192. Okay, I go through so many steps here, and you should be able to do with practice mentally, and would have to can skip most of the steps. Or all right, let's do some exercises now. You can do 48 times 52, 73 times 77, 2010 times 1998, 3024 times 3012, and some more. Okay, let's go on to the next section now. Next section is we'll study square of numbers ending in 5. So we'll take a number ending in 5 and do the squares. Okay, let's see how it works. Okay, let's continue with the square of numbers ending in 5. First example is 15 times 15, square of 15. 15 ends in 5. Okay, let's continue. My base I'm going to use is 10. Okay, let's take another example now. Next example is 45 squared, 45 times 45, and our base is 40. I'm going to choose a base of 40. Another example here is 115 times 115, square of 115, and in 5, two digits on left are 11, and the base number is, we choose a base of 110, which I got from 11 times 10. Okay, this is 4 times 10, this is 1 times 10. Okay, let's continue. But next we do is find deviations. So it's 15 minus 10 is 5, 45 minus 40 is 5, 115 minus 110 is 5, is 5 plus 5 all the way. Okay, so here's my deviation 5, 5 plus 5 plus 5 plus 5 and plus 5. Now we're going to find a left by cross applying the deviations. So we can do 15 plus 5, 45 plus 5, 115 plus 5. Let's go do deviations. Left is cross apply the deviations now, which get 20, 50, 120. This is a proportional base. This is natural base. This is a proportional base. So we resolve proportionality now. 20 times 1 is 20. 50 times 4 is 200. 120 times 11 is 1320. Continue. Okay, so these are my, after resolving my proportionality, on left I have a 20, 200, 1320. Okay, let's continue. Multiply vertical in the right, which is plus 5 times plus 5, 25 here, 25 here, 25 here. Okay, let's continue. So we get 25, 25, and 25. Now, notice that we have 25 all the way. Okay, 25 on the right, 25 on the right, 25 on the right. Okay, and 0 on the left. Left number ends in 0, left number ends in 0, left number ends in 0. Another thing is that 25 here, only one digit is allowed. The 2 from 25 get carried to the left, 2 get carried to the left, 2 gets carried to the left. This 2 would slide right into this 0, this 2 would slide into this 0, and this 2 would slide into this 0. Okay, let's continue. So 2 slides into 0 on the left. Answers are 225, 2025, and 132. 25. Okay, let's continue. Answers are 225, 2025, 1325. So 25 on the right, 25 on the right, 25 on the right. It's 2 here. 2 is equal to 1 times 2. This 20 here is equal to 4 times 5. This 132 here is 11 times 12. So on left part, we have been doing by 1 more than 1 before. It was 1 here, it's 1 times 2. It's 4 here, 4 times 5. Here's 11 here, 11 times 12. Okay, let's continue. On left of 25, we had 2, 1 times 2, 20, 4 times 5, and 132 equals 11 times. Now let's do some examples of squares of numbers ending in 5. Okay, let's go. First example is 65 times 65, which is 65 squared. On left, it's by 1 more than 1 before. 6 times 7 is 42 on left, and 25 is on the right. 5 times 5. Okay, answer is 6 times 7 is 42, and right part is 5 times 5 is 25. Answer is 4225. 65 times 65 is 4225. Let's another example here. 25 times 25. On left is 2 times 3, and right is 25. So 25, 2 times 3 is 6, right is 25, answer is 625. Another example, 0.125 times 0.125 is 12 times 13 on left, 156, 25 on the right, it's 15625, and I need to have 3 digits after decimal and first 3 digits after decimal here, so on the right. So we would need a 6 digit after decimal, so for that we would get 0.015625. So answer is 12 times 13, 156, and 25. Answer is 0.015625. So extra 0 we added because we needed 6 digits after the decimal. So right now this is 1/8, this is 1/8, 1/8 divided times 1/8 is 164. So we just computed 1/64 is equal to 0.015625. Continue. 155 times 155. Another example here. Left. by 1 more than 1 before. 15 times 16 is 240 on left, right is 25. 5 times 5, 2402. Okay, let's continue some examples here. Digits on right add to base number and digits on left match. Okay, let's see what I mean. 11 times 19. 1 plus 9 on the right add up to 10, which is base number, and 1 on left match. Okay, let's do by base numbers. Base equal to 10. Okay, and then what do we do? Compute deviation. Deviation 1 is plus 1. 11 minus 10 is plus 1. Deviation 2 is 19 minus 10 plus 9. Okay, on compute left by cross applying. 11 plus 9 or 19 plus 1 is 20. Okay, on the right, vertically multiply the deviations 1 and a 9, which is 9. Base is 10. Number of zeros is 1. Number of digits allowed on the right is 1. And 9 has a 1 digit. So answer is 209. Okay, and also you can do 10. Base times left plus 9. 10 times 20 plus 9 is 209. Okay, let's see. 209 is like 2 and a 09, where 2 comes from 1 times 2. What is 1 times 2? By 1 more than before. A 09 comes from 1 times 9. 1 times 9 is only one digit, but we have a 09 here because this 2 on the left is like a 200, which is, and to that, the two digits on the right. 200 come from 10 times 20, just like here. Okay, so when there's only one digit comes on the right, and then you need, for multiplication, you actually need two digits, and 09 comes in here. Okay, so let's see what happens. On left, it's by 1 more than before. 1 times 2. On the right, it's multiplication right digits with the padded with 0. Let's do some examples. 33 times 37 is, on left, 3 times 4 equal 12. On right, 3 times 7 is 21. Answer is 1221. Okay. Example, 56 times 54. On the left, it's 5 times 6 is 30. On the right, 6 times 4, 24. Answer is 3024. Example, 225 times 275. Here, the two digits on the right, 25 and 75, add to 100, which is the base number. Okay, so on left is 2 times 3 equals 6. Right is 25 times 75, which is equal to 25 times 25 times 3. And 25 times 25 is 625. We just did it recently. And times 3 is 3 times 6 is 18, and 3 times 25 is 75, 1875. So 6 on the left and 1875 on the right. So answer is 618. Okay, now you can do some problems here. Let's try this problem. 75 times 75, 71 times 79, 72 times 78. Again here, 1 times 9 is only one digit. You would need to pad that with 0. It's 09 on the right. 0.25 times 0.25. Similarly here, 0.21 times 0.21. 1 times 9 is one digit. Okay, so we have to do, watch out. Okay, and some more. 125 times 125, 3.1 times 3.9, and so on. There's some references here, and our teacher's manual is my main reference. Tirthaji uses this method in chapter 1, and Glover's book, Vandana's book, and Bhatia's book, they all have sections on base multiplications. Okay?